Thank you, EPR, for giving this opportunity and this prestigious platform to discuss about a very relevant topic in the present scenario. That is the RE integration targets. When we talk about the targets, it comes with the challenges and opportunities and solutions in reference to our nation. When we talk about the power system, the most important things that comes in our mind is a system that is giving you the quality, that is providing you the reliability, that is redundant in nature, that is smart, that provides stability, and above all, it ensures the safety and sustainability. The power system that itself is a flexible, that can integrate renewable, that is efficient, and last but not the least, the cost effective. But to have that system that I have talked about, you have to work very hard. You have to work very hard to achieve the same thing, to make your system cost effective, smart, safe, efficient, flexible. Then you have to understand the power sector, what that power sector in my country is. It starts from generators, there some transformers are there, then comes transmission line, sub-transmission line, sub-transmission line, distribution systems are there, then goes to my consumer finally. And when you talk about the power system, to have a power system, you need some energy sources. And there are two categories of energy sources. We have renewable energy sources that comprises of wind, hydropower, solar, geothermal, biomass. At the same time, if you talk about non-renewable energy, that is oil, gas, coal, natural gas, nuclear. Before I go straight to the present scenario, it is quite important and pertinent to understand the total scenario from the date of independence. In 1947, the total installed capacity of India was only 1.36 gigawatt. If you talk about 2020-25, September, the latest data available on the side of CA, that is 500 gigawatt. And the projected total installed capacity is going to be around 900 by 2030 as per the CA latest data available on the site. We talk about the per capita consumption in 1947, that was 16.3 unit kilowatt hour. If you talk about the latest available data, that is 1390, and it is projected to be 2000 kilowatt hour. In 1947, there was no interstate transfer capability, inter-regional transfer capability was there. Now it has reached up to 120 gigawatt, and it is expected to reach around 150 gigawatt by 2030. We used to have 5 different regions working in isolation. But in December 2013, the dream of one nation, one grid could be fulfilled. And now we are one nation, one frequency system. I've already stated that that is a figure up to March 31st, 2024. The latest figure is 120 gigawatts as per the latest reports available on the sites of CA. Whatever I have mentioned, that was a conventional system when there was generator that was far away from your load, and there was transmission line, then sub-transmission line distribution system. But in the present scenario, there are distributed energy resources. The consumer is not consumer at all. The consumer is prosumer. It is helping the nation in the generation of electricity. There are waste to energy plants are there. Their heat recovery systems are available. There are small and big wind stations, biomass stations have already entered in my systems. My system is now not a simple one, it has become complex. When your system becomes complex, you have to address this problem meticulously. You have to look at each and every components. Accordingly, you have to make proper planning. You have to provide proper protection. You have to look at their technical issues. You have to look at the economical issues. You have to look at the social issues, policies, regulations, infrastructures. You have to provide the proper market to cater that change in my system. The system is not a simple system. It has become smart. You are direct communicating with each and every constituents of your systems, even with your consumers. All data are available online. Real data can be captured, can be seen on the internet. Every parts of my systems are communicating. Used to depend on that thermal power plant. Only sources of energy in the previous days were thermal power plant. We were totally dependent on coal. But we have moved toward that sustainable power sector where solar, wind, biomass, hydro, small hydro have started giving their contribution towards sustainable development of India. All these things happens in the climate change conference UK 2020-21 Glasgow, and five goals were given by Honorable PM Saab that are the goal of our nation. We have to achieve net zero by 2070. We have to reduce total projected carbon emission by 1 billion tons starting now till 2030. We have to increase renewable energy components to 50% of total energy requirement by 2030. We have to reduce carbon intensity by 40%, 45% by 2030. And we have to reach 500 gigawatt by non-fossil energy capacity by 2030. To meet that target, Panchamrit declared as a nation mission need proper planning, determination, policy and regulations. We can't ignore that elephant in our system. We have to discuss that system. We have to work together. We have to frame a policy. We have to frame regulations. We have to show our determination to implement the regulation and achieving the targets of green power systems, sustainable power system. We have to work against the clock. We have to work very hard to overcome the challenges associated with the targets of my renewable energy. A very first step taken by Government of India, that is in the shape of PM Suryodaya Yojana 2020-24. 1 crore household will have that solar panel. But this is the one side of the coin. The consumer, we have already made consumer. But every change comes with the challenges. When you talk about the challenges involved, there are challenges of inertia, there are challenge of bidirectional flow of power, there are challenges of fault level, the challenges of harmonics, the challenges of anti-aliasing scheme, just challenges of coordination of relay, low inertia, and most important, waste management of renewable system, be it battery storage systems or solar panel. We have to make framework and policy for waste management of that renewable targets we have in India. It's a matter of proud. We have given commitment of 2030, but we could achieve it in September 2025, 50% of power capacity from clean and non-fossil sources. We could achieve it 5 years early than the targeted year. But the journey is long. We have to work together. Still many milestones to be achieved. The latest data of total installed capacity, 500 gigawatt total installed capacity. If you talk about non-fossil, it is 51.13, more than 50%. I already mentioned that thing. And you talk about the contribution of various sources. Thermal contribute 48.87. Nuclear contribution is 1.75%. Hydro is 10%. RES, naval energy sources, contribute around 40%. We have to look at our targets, projected installed capacity by 2030 in gigawatt. We are expecting 900 gigawatt, and solar contribution will be 40%, wind will be giving 13%, bio will be 2, hydro 11, nuclear 2%, and we will reduce that 49%, that is presently we are getting that 49% from thermal. By 2030, it is to be reduced to 32%. It's a big target to be achieved. It comes with the challenges. We have to take that challenges, that bull by the horn. If you want to understand the important challenges of the targets, there are some technical targets like intermittency, grid stability, weak transmission systems. There are some economical issues, financial stress, high cost, social issues are also involved like land conflict, ecological concern. There are some policies issue, fluctuating rules, weak renewable purchase obligation enforcement, infrastructures, poor monitoring, lack of EV support, markets, weak trading markets. We have to overcome all these things to meet the targets already declared by Honorables PM Sir. There another challenges are there: forecasting, storage, congestion, protection system, economics, cybersecurity, waste management. There are some technical challenges: reduce fault currents, bidirectional power flow, islanding issues are there, coordination complexity, inverter behavior, fault detection system, harmonics, dynamic topology, lack of inertia, communication system dependency. And within our systems, assets failure, that is because of loose connection, incompatible connector, poor design, inverter fault, cable damage, bad installation, lack of maintenance, component failure, lightning strikes. When you talk about the renewable energy integration challenges, but what are the rules and regulations? We have to understand that thing also. There are three major rules: CA Safety Regulation 2020-23, Grid Connectivity Regulation 2007, then Distributed Generation Resources Regulation by CA. These three Bibles must be understood. Then some IEEE guidelines are there. Yeah, IEEE 159 that gives references about the harmonics control, the 1547 series interconnection of distributed energy resources, IEEE 929 and IEEE 2800, and CA and Indian Electricity Grid Code. And specifically fault right through, LVRT, HVRT, reactive power capability, frequency response, and the harmonics. We have to ensure that thing. This is a summary of all standards. These are the technical guidelines. CA and Indian Electricity Grid Code is mandatory technical standards. And Grid Code is mandatory operational code. And these are legally mandatory. And whereas IEEE standards are reference and voluntary, then comes the important aspects: grid compliance study. It is a technical assessment conducted to ensure that a new power plant, especially renewable energy like solar or wind, can be safely and reliably connected to the existing electricity grid without violating technical standard or affecting the grid stability. Objective of this study is to check whether the plant can operate safely within a grid voltage, to verify the fault right through capability, LVRT, HVRT, to ensure reactive power and voltage control compliance, to confirm the protection and the metering systems are in place, and to evaluate the impact on power quality like harmonics, flicker, voltage, and fluctuations. There is need to address the solar waste issue, that is called waste management. When I say the recycling of the waste management, we don't have large scale recycling facility at present. The cost is high, low recovery values is there, technical complex material, weak regulation for extended producer responsibility enforcement. There is no clear decommissioning policy, battery waste management, mismanagement, health and environmental risks are involved. When I say environmental and health issues, there are issues of land, wildlife, water, waste, emission, noise, storage, and climate. We have to address all these issues. This is not the end, it is a new beginning. We have to work together to make India a safe country, to achieve the targets, to overcome the challenges of integration of renewable power in my systems. This is difficult but not impossible. And with the efforts of all, definitely we can achieve the targets of renewable integration into my system.